The AES encryption process starts with a plain text. This plain text is then converted into hexadecimal for the computer to read. This hexadecimal table is our state, and our state is then XORed to get our cipher key. After we have this cipher key, we perform key expansion, which will give us 10 other keys that are based off this cipher key. So to start off the AES encryption, we will take our cipher key and add that as a round key. And then for the successive steps, we will perform subbytes, shift rows, mixed columns, and we will add that round key into our encryption process. All right, so we have our round key here, which was derived from our cipher key, and AES encryption performs a shift cipher of each of the bits in our given round key, which will result in a new state, which is right here. After that is done, we will then shift the rows. Each row is shifted a different value. For example, the second row is shifted over 1 byte, the third row is shifted over 2 bytes, and the third row is shifted over 3 bytes. After shift rows is done, we can then mix columns. We do this by multiplying each column by the Rindahl-Gallows field matrix. Once each column is multiplied by this matrix, it will result in a new state, and then with this new state, we add this to our key schedule, which will then go back to our round key for round key 3. And we repeat this cycle until we get to our final round, which we will not mix the columns because at that point it gets redundant and it will save time to not mix the columns. So once we have gone through all the round keys, which will be 11 rounds, assuming that we are using a 128-bit key size, what results of our round keys going through our algorithm is a state of encrypted text, and this is why AES works.